My dear students, so far we have seen in our previous videos different forms of straight lines, equation of different forms of straight lines, and using those results we have solved some problems, and also we have determined the shortest distance between two given straight lines and so on. Now in this video I am going to introduce the topic planes. Different forms of equation of a plane. In that, the first form is equation of a plane in normal form. Equation of a plane in normal form. This is the plane in YZ plane. A YZ system, coordinate system. At OX, OY, YZ is a three-dimensional coordinate system. In this, we have determined a plane. This plane, its perpendicular distance from the origin is P, and d cap is a unit normal vector to the plane. Using this, and A is any point in the plane and P is also a point on the plane. From the point P, the position vector of the point P, OP is R vector. The coordinates of P is X, Y, Z. And the coordinate of the point A is x1, y1, z1, like that. And the point A, the plane is of distance P from the origin, and the d cap is the unit vector. Now we have to find out this equation of this plane, and this equation is called normal form. So the plane is at a distance P from the origin. The given plane is at a distance, the distance from the origin. The given plane is at a distance from the origin O is P, that is the distance OA is equal to P. A is a point, any point on the plane, and d cap is the unit normal. D cap is the normal vector, unit normal vector is the unit normal vector. D cap is the unit, cap notation indicates the unit vector. D cap is the unit normal vector to the given plane. The plane is at a distance P from the origin. The plane is at a distance from the origin is P. That is OA equal to P. D cap is the unit normal vector to the given plane. And P is any point on the plane. P is any other point. And P is any point on the plane. Whose position vector OP is, whose position vector of the point P, OP vector is R vector. Since OA is parallel to the unit normal vector D, OA vector is, magnitude is P and the direction is d cap, therefore P into d cap. So OA vector is parallel to the normal vector D, unit normal vector D, therefore it is of magnitude P and the direction d cap, therefore OA vector is P into d cap. And you know that the OA vector and AP vector are perpendicular. Each OA and AP are perpendicular. So the vector OA, and the vector AP are perpendicular. Perpendicular vectors. OA and AP are perpendicular vectors. Therefore, the vector AP dot OA equal to 0 vector, because these two vectors are perpendicular. OA and AP are perpendicular. Therefore, OA dot AP equal to 0. What is AP? AP vector is, you know, by definition, AP vector is OP minus OA dot OA equal to 0. What is OP? OP vector is R vector minus OA vector is P into D cap dot OA vector is P into again D cap equal to 0. OP vector is R vector and minus OA vector is P into D cap vector dot OA vector is again P into D cap vector. Since P is a scalar, it becomes to the right hand side becomes 0 by P is 0. This is R minus P into D cap dot D cap equal to 0. Because P divided by 0, if you bring it to the right hand side, it becomes 0 by P is 0. Again, R minus P into D cap dot D equal to 0 by taking dot product, distribute to R dot D cap equal to, if you bring that back, or otherwise you only write one more step, minus P into D cap dot D cap equal to 0. D cap dot D cap is unit vector, I dot I is 1. Similarly, J dot J is 1, D cap dot D cap, these two are unit vectors, D cap dot D cap is 1. Therefore, R dot D cap minus P equal to 0 because D dot D is 1. So again this is R dot D cap equal to P. R dot D cap equal to P. This is the normal form of the equation of the plane whose distance from the origin is P and D cap is the unit normal vector of the plane. So R dot D cap equal to P. That's all about the vector equation of the plane. Okay. So normal form of the equation of this plane is R dot D cap equal to P, where R is the position vector of the point P from the origin and D cap is the unit normal vector to the plane and P is the distance of the plane from the origin. And I said D cap dot D cap is equal to 1. Therefore, we get R dot D cap equal to P is the vector form of the equation of the normal equation of the plane in normal form. Now, Cartesian form of this plane. Cartesian form of this equation of the plane in normal form is, let you know that the vector R vector, position vector of the point P is R vector is XI plus YJ plus ZK because the point P is denoted by the coordinates X, Y, Z. So R vector is XI vector plus YJ vector plus ZK vector. And D cap is the unit normal vector. And where L, M, N are the direction cosines of the unit normal vector D cap, where L, M, N are the direction cosines of the unit normal vector D cap. Direction cosines of the unit normal vector D cap, therefore D cap vector equal to Li plus Mj plus Nk. Therefore D vector is L into I cap plus M into Ij cap plus N into K cap is the unit normal vector of the vector D cap, where L, M, N are the direction cosines of the unit vector. Now, substituting in this relation R dot D cap equal to P implies R is Xi plus Yj plus Zk dot Li plus Mj plus Nk equal to P. Substituting the components of R vector is Xi plus Yj plus Zk dot D cap is Li plus Mj plus Nk, which is equal to P, you know. Now, dot product of two vectors, you know, I dot I is 1, therefore Lx. The J dot J is 1, My. plus k dot k is 1, n is that. The rest of the vectors are 0. I dot j, I dot k are 0, j dot I, j dot k are 0, k dot I and k dot j is 0. You get only I dot I, Lx, j dot j, my plus k dot k, n is that equal to p. So this is the Cartesian form of the equation of the plane in normal form. This is vector form, this is Cartesian form. Okay? So now certain remarks for this normal form of the plane. First one is, if the plane passes through the origin, if the plane passes through, if the plane passes through the origin, if the plane passes through the origin, then the perpendicular distance p is 0. If the plane passes through this origin, the distance p becomes 0. Therefore, its equation is Lx plus my plus nz is equal to p should be 0. So Lx plus my plus nz is 0. If the plane passes through the origin, distance of the plane from the origin is 0, therefore Lx plus my plus nz is 0. It's this one remark. If the plane passes. If the second remark is, if d is any vector, it's not a unit normal. If d is a normal vector, but it is not unit vector. D is normal vector, but not unit vector. D is any normal vector. D is any normal vector, but not unit vector. Okay, if it is the case, d cap, any vector whose unit vector you can write as d cap equal to d vector by mod of d vector, This is the formula for finding d cap. So d cap equal to d vector by, okay, if d is any normal vector, not unit vector. If d is any normal vector, but not a unit vector. If it is the case, if you convert the d vector into d cap, that is d cap equal to d vector by mod of d vector. Therefore, you know that the result r dot d cap is d vector by mod of d vector equal to, what is that? P. Instead of d cap, I can substitute d vector by mod of d vector, because d vector is converted into unit vector by d vector by mod of the vector. That is again r dot d vector, not d cap, r dot d vector equal to p into mod of d vector. That is equal to r dot d vector equal to q, where q is q equal to p into modulus of d vector. So this is the normal form of the equation. If d is any vector and q is not the distance of the plane from the origin, it is not that q does not represent the distance of the plane from the origin. Q is any distance. It's a scalar. R dot d cap equal to q. Q is not a distance of the plane from the origin, and d cap is not a unit vector, it is a normal vector. Therefore, r dot d vector equal to q is the normal form of the equation if the vector d vector is given. Okay, that's all.